Hello everyone, back again after a long absence. Alright, hands up. How many of you thought I'd died? Well, I didn't, so I'm back in the workshop. Bit of an update for you. Lost interest in the knurling tool I started to make. That's been put back in the box, and well, maybe I'll attack that another day. DRO conversion also on the mill. Thought about it, bought some bits as you've seen maybe, and thought better of it. During the winter had a cataract removed, bit of laser eye treatment, and now waiting for some new glasses. Been bloody cold out here in the winter, and that's not done my rheumatism and arthritis any good, so that's the main reason I've not been in the workshop. However, I haven't been entirely lazy. Well, I have, I suppose, by watching YouTube videos, and my eye was taken by this. I'll try and tip the camera down. It's a new mill. Yes, I've gone out and splashed some more cash. Well, splashed some more credit card actually. And I've ended up with this. It's all set up now, virtually ready to go. I just need to pluck up a bit of courage to actually switch it on and get it milling some aluminium. I'll just talk you through what I'm hoping to make with it. I'm not using any of the examples that came with the machine. I've seen loads of those on YouTube, and possibly you have too, and maybe you're as bored with them as I am, so I thought I'd make something different. This is a screenshot from Atom, in which I designed the clamps, and they're orientated like this, both down on the lower plane for ease of manufacture, and it shows up better than the 3D model which I've printed out in black PLA carbon fibre reinforced, but possibly you can see the action if I get the camera angle right. This small part on the end slides up and down on these angled ramps, so that when this is clamped to the bed rigidly, this is brought up to the edge of the workpiece on that face, screw down on there, and that forces the clamp down the ramp and in that direction into the workpiece, holding it hopefully firmly. So there we are. This is the setup. It's connected to the computer now. All I have to do is download the G-code file for the first operation. When I do that, I'll set up the Z-axis probe, which I've installed in the spindle. That'll come down and trigger the height switch here. Then it'll come over, and I think it will, if I select it, it will work out or describe with the inbuilt laser stroke bright light in the spindle the work area, just so that I can make sure that it's contained within the confines of the workpiece. Then the Z probe will come down, touch the work to work out the offset, go back to this position, and then the program will prompt me to change the bit, so at which point I'll put in a 4mm 2 flute end mill in place of this, and press go, and fingers crossed it will start the first operation. I can't remember whether that's going right through to the bottom with a slot. That's this slot, or whether I'm going to do the contour of the cutout first, so that there's less for it to cut through. I can't remember which I decided to do now, but that'll all come clear when it starts churning out metal. Right, okay. You may hear the 3D printer going away in the background. That's I'm not going to stop that. But here we go. What I've done, I've loaded up the file to cut out the shallow pockets in the top first, so that when I come to do the deeper ones, there's less far to go. I've set it to this is the 3D probe that's in here at the moment. When I run it, it'll probe down to the height switch here, come over to the work and probe the height. But first it will come along and show a red dot around the work area, just to check that I'm not going to run into anything interesting. And after that it will go back to the rest position here. There'll be a loud beep and I'll get a message on the screen to change the probe for a cutter, and this is the one I'm going to use. 4mm diameter 2 flute end mill. I've got air assist on. Well, at least I've had the compressor going. It's up to full pressure. When I pull this out, it should blast out some air. At least that's the theory. Doing now. I don't know how much I'll need to blast it out, but probably a bit more than that, I would think. There we go. So when the pressure drops, the compressor will kick in, and that will frighten me and you, I expect, at the same time. So here we go. Run. Whilst that's moving, there's the red light. That shows the limits of where the pockets are going to be milled. And here goes the Z probe. Boink. That will now go back to the rest position, and that noise tells me please change to tool 2. There goes the compressor. Out comes the Z probe. And goes the mill, or the milling cutter, and well, I'm going to have to close the lid because I don't want chips flying all over the place. And let's hope we'll both be able to see. Right, it says then press confirm to proceed. So I'm pressing confirm on the computer. The spindle's now descending, and we'll measure the length of the end mill, which is done, and apply the offset. And this is where I hold my breath. There goes the spindle. I've used fairly conservative feed rates, using a spiral ramp into the material. Don't like the sound of that. I've paused that. Well, that didn't go well. I think the spindle speed is not high enough. I'll have to go back to square one. Right, well, here we go. Second attempt. You'll see that I've moved the stock round because that started to mill in the wrong place as far as I was concerned. So I'm going to run it again. It'll probe the Z height, having first marked out, well, not marked out, but delineated the work area with the red light. Sorry about the compressor coming on and off, can't help that. Then we'll go back, it'll prompt me to change to the 4mm end mill, which I'm going to insert a bit further than it would be with a collar fixed, so I'll have less stick out. I've changed the CNC files so that the spindle will run at 12,000 RPM and not the previous 5,000, and at 500mm per minute feed rate. So we're all ready for that. I'll press run. And on cue the compressor stops. Change tool. Probe is in, so I can confirm that. There it goes. Down to the height setting tool. If you can see the red light, it's tracing out. Yeah, well, that's going to waste quite a bit of aluminium, but I'd rather that than it clash into the holding clamps here and possibly around there as well. Down we go until it hits the top of the stock. It can now go back to the resting place. Beat for me to change the tool. I just knocked the camera, sorry about that. There we go. Knocked it again. Now going down, measuring the tool length, work out the offset, clunk. And fingers crossed, something will happen. Spindle's spinning up. Spiraling, or not spiraling, it's helical feed into the material. Doesn't sound much better. press on. If something breaks. No, like that. It's stopped. Oh dear, oh dear. I can't remember whether this is third or fourth time, but I'm hoping that I've got the G code right this time, so without further ado or explanation, I'll press on. Oh, that's a good start. Oh yeah. Confirm I've got the probe in. I'll confirm that. Work out the work area, and this is where I started before, so that's in there, yep. Now we go to probe the Z height. Standing by with a tool change. Yeah, that's the prompt for me to take the Z probe out and put the 4mm. There we go. Got the air assist going. Trying not to kick the tripod, and well, here goes nothing, and it goes travelling down to measure the tool height for the offset. That sounds more like 12,000 to me. Seems to have slowed down for some reason. That's nearly. Quite small step overs and step downs, so I'll not make you watch all this. first recess took about, I don't know, about 6 minutes. I didn't actually time it, so see how quickly this one goes, presumably about the same time. Come back in a minute. I think the next run will be the last one in this. Oh no, that was it. There we are, you missed the last run. I didn't press recording quickly enough. So that one's finished. And I'm glad I've got a enclosure. It's just... oh. Switch on. Let's finish those two pockets and just running my fingers across the top. I think they will benefit from a light chamfer, so maybe I'll add that to the list of jobs to do. And well, I count that as a success for the first one. I see no reason why the others shouldn't follow suit, but I think that's probably enough for this video. So if you have been, thanks for watching, thanks for putting up with it, and hope you'll come back next time when I carry on doing some more metal mangling.